It's my pleasure joining this community and discussing on this topic. I'm sharing my screen very quickly, and let's uh, let's discuss. So, as we were discussing about the questions, what I will say is I will go through the presentation, and it's not like the presentation thing. We will discuss uh, what whatever topics that we will cover, and I will pause in between for 5 minutes after every major part that we cover, so that if you have any questions in that particular section, you can ask that. And as you correlate ideas and you still have doubts regarding, how this relates to that or how does this work, then obviously we'll having a longer Q&A session at the end. Cool. So, what are we discussing today? The topic of discussion today is building multi-genetic systems. That is the focus with Claude Agent SDK. Claude Agent SDK is the language that will is the language we'll be speaking. In terms of how you exactly implement these concepts. But the very idea of it is you know uh, start from the very ground up. We will start from what really is an agent, what is not an agent, and from there we will build up what are the best practices. How do you really from the first principles create a right multi-agentic systems. And it is not about, it starts one layer above. It's not even about writing the right set of prompts, just about setting the right set of prompts, or um, programming your way through it. So, what I've been working recently for last 3 years, I will say, is working initially with LLMs and then with agents to build autonomous systems. So that's what I specialize in. And at Transilience, we have been working on building a security LLM OS, which we call security OS, that is built to do the handle all of the buckets in cybersecurity, correlate data, and take real ownership and agency over the outcomes that you want as a customer. So before we really, go through all of this, that what really is an agent, how do we build an agent, what is not an agent, and all of it, I'll start with some numbers. Uh, why do we exactly need to learn this as of now, and especially as cybersecurity professionals? Uh, I think all of us have heard of the famous Jim exploit incident that happened between OpenAI and Hugging Face. Some numbers right there in front of you. 17,600 attacker actions were done in just 108 hours. And all of this was, there was a private scratchpad that was created by the agents on which they were communicating what was going on. And even though when it was removed, what they did is that, okay, it looks like some agent is leaking our mission. And then in order to achieve their objective, they also tried to anonymize it and uh, prevent that information from leaking, right? So what happened exactly there is, what it is exactly tells you is that it's not science fiction that we have autonomous agents that are communicating with each other and able to execute tasks without any human oversight. And the pressing issue there is that the every numbers that you're seeing here are from the attack side. When Hugging Face tried to, run TDFIR on this particular operation and see, check the logs, what was going on, how all of it happened. The frontier AI models, as we know it, all of the Anthropic, OpenAI, all of those frontier models, did not support them because they're like, oh, we cannot support you with this cybersecurity operations, and you need to do this and do this, that. And hence, all of the LMs were deployed on prem and the operations were in there. So the attackers are able to, separate the responder from what is the target, do all of the operations. But as a person who is in blue team, or a person who's aiming to defend your own infrastructure, you need to learn about how these systems work and how you can build a system that works uh, in your favor, because attackers are not waiting to uh, go something go and do something against you. So what really is an agent? When we look at this term agent, which is it's going viral, in 2025 is the this was the year of agents, and now we are looking at multi-agent systems in 2026. What happens in most of the cases is that it has a static orchestration layer to it. That I have a program in which I'm doing some bunch of LLM calls in between with some context. It is giving me some answer back, and I'm using that with my code to execute some tool calls and say that it is an agent. So what we need to understand here is that is not an agent. What all is missing? Runtime planning, dynamic adaptation, decisions follow pre-coded branches rather than emerging from continuous model reasoning, as you can say. What what it exactly means, right? When I write a piece of code, let's start there. When I write a piece of code, okay, it has an execution flow to it. Is that from start to bottom, it will flow exactly in this manner. Uh, if the system that you build around LLMs has no power of decision making, that it can decide it needs to go this way or that way based on how the input data, the long running context, how it is planning, based on these context that we are getting. If it is not changing the execution flow of your code from start to end, the agent does not have that decision making power, and you are just making LLM calls to get some information out of some context that you're throwing at an LLM. And that is not an agent. So a system is agentic only if it has dynamic execution flow at runtime. What it means is that dynamic execution flow means the agent is taking decision and then deciding what course of action needs to be taken at runtime based on what is the data that it is getting. Plans at runtime. What it means is that you don't have a fixed DAG. Right? So what usually happens is when we talk about agents, uh, we say, okay, this is a piece of code. I have 5 pieces of code, and I have assigned all of them to a node in the graph, and they are running in this way. If else, all of regex, all of that. That is not. If you have a fixed DAG, a fixed execution flow, the decision making is built in the code, then that is not an agent, right? And that is also fine. We don't need agents everywhere. But let's not call that an agent. Second thing, it adapts to the results. Adapts to the result is what it means is that the next step or the next action that the system is taking depends on the previous state, which basically means that you are over a long horizon or a long amount point of time. What are the actions or the steps or the stages that have been happened, what stages have been crossed, and on the basis of that, the results are being changed, right? And third thing is reasons end to end. So when you write a piece of code, it starts, does something, done. Like ownership still lies on you. Uh, it's not on the code. Code is solving some part of it, but the real decision making, the judgment, all of that still lies with you. Right? So when we look at this term agent, right? Uh, if we go to its English roots, it comes from agency, and it is not something fundamental. Is not just a software programming construct, but it is a property of humans as well. What agency means is that I need not to be told what I need to do. Whatever tasks that are right in front of me, I pick those tasks and execute them end to end and tell me, hey, this is done. That is agency. And now the entity that does that, that is able to execute a task end to end with reasoning and come back to me and say, okay, hey, I need your help for this sort of thing. Or this is done. These are the decisions that I make because of this and this. So that is an agent. And that is what we are trying to implement in software. So, for example, you're calling some LLM with some prompt and input. It is giving some result, and you have some condition on top of that result, and then you're returning something. This is not an agent, right? You're just wrapping a model call inside some pre-written logic that you have. The decisions live in the code itself, not with the model. What happens in runtime planning is that you can summarize any agentic system in these 5 lines. Is why it is not done, gather the context, plan what needs to be done, act on it, and then verify whether it is done or not. Fundamentally, this is what all of the agentic systems are. Right? If you see here, nothing has been hard coded. The decisions live with the model at each and every step of the pipeline. So this is the difference between static orchestration and runtime planning, and this helps us define. It will, you can use this as the guiding principle to differentiate what is the difference between an agent and not a workflow. Whatever you see on internet, on GitHub, you can go through the implementation, the philosophy, how things have been implemented, and judge, is it really a DAG with some LLM calls, or it is really an agent that is doing the reasoning, maintaining the context, taking the ownership of the outcomes? So what we will see here is, we will go through what is Claude Code, what are the best practices, how you build hooks, how you build sub-agents, how you build MCP, what are the principles, what are the best practices, what are multi-agentic systems. But even before that, we need to start with the very foundation. The very foundation is that philosophically, from ground up, from first principles, what is a guiding principle that you can use to build agentic systems, right? So I I think it is a pretty famous painting. I would like you all to look at this painting, right? The Vincent Van Gogh, Wheat Fields with Cypresses. So if we see this painting, what happens is you will see there are some colors, there is well-defined boundaries between them, but the colors have been mixed in such a way that there are layers to the colors, and that differentiated layers of the colors and the way they have been presented is what making this painting come alive, right? If I would have done, if I would have not have done that layering of the colors, and I have just, let's say, painted blue all over in the sky, or there are no shades of white in the grass, it would not have been that beautiful. Also, if I do not have the right boundaries in this painting, right, between the sky and the land and the trees and the flowers, and just mixed up the colors here, where it looks, no, it is the right placement in between of giving the freedom to colors to blend and create shades, but also having boundaries so that the system comes alive and expresses the meaning. That distinction is very important. Why am I explaining this painting? You must be wondering why I'm explaining a Vincent Van Gogh painting to you. Because that also what exactly happens when you implement this runtime planning, when you implement agents, right? So designing an agent, as I mentioned in the bottom line, is drawing the line between these two spaces, the latent space and the deterministic space, deliberately. Whenever you feel like your agentic system is not intelligent enough, or it is not hallucinating and not giving the right outputs, right? Or, it's not understanding my intent, all of that, boil it down to this very fundamental principle. Go to your code, whatever you've written, and check, have you drawn these boundaries right? The distinction and the boundaries between the latent space and deterministic space. So let's understand what these are. What does latent space means is that the model is making a judgment, right? So what happens is, initially, the model is trying based on it is trying to predict the next circle, right? So when you are making the model make the judgment, it has some input data and it's trying to make a judgment out of it. So why we calling it latent space is that it is contextual reasoning, right? It has taste to it. It has ambiguity as in the models has its own like accepted biases, right? Or preferences over doing things in a certain way. things might be plausible but unverifiable. Just like, if you dip your brush in the paint color and just put it on a white paper without any thought. Uh, Third thing is scale poorly with the size of the input, and the output might be different everywhere. So it is like, imagine it as wild imagination, right? Latent space is that you can imagine what you can comprehend, think, uh, do whatever is an imagination. And third thing is deterministic space, right? Deterministic space is the harness around it, the program that executes reliably. So whenever you have, let's say, a C++ script, for example, you are implementing DFS on some graph, right? And you have a script that does that. For a given set of inputs, I have a given set of outputs, and that is for sure each and every time. That is not the case with the latent space, but that is the case with the deterministic space. It has hard verifiable computation. I can, for example, for browsers, I can build playwright tests. I can build PyTest checks, right? I can have SQL regex, math type checks. And as we discussed, it case linearly, predictably. It's a well-defined. It's a system design. We have a whole subject behind it, right? And fails loudly when it fails. So what it means is that if your code is not working, it is not working. But that is not the case with the model, right? It is, imagine it as your imagination. You might imagine something wrong or paint something wrong, which is not wrong, but not right. So the distinction that we need to do is that the boundary between you along the model or you allow the model or the agent that you have built to think enough, to reason enough without being constrained by the harness. But the harness is putting the right, you can say, hooks, checks, context management, right checks as the model is thinking through without interrupting it, to make sure that the intent is met. That right makes it very important, right? Where, as I mentioned, where latent ends and deterministic begins isn't drawn with the ruler. It is a judgment call, right? So you cannot say, okay, I have this fixed harness, and I have this fixed model, and it will just go work for each and everything that you can do with it. It's not like that. You have to make a judgment call. Okay, where do I need to place a hook? What are the tool calls that allow this in this hook? Okay, what if the context changes in this what is the context step? What if this is in this direction and the model is trying to execute a particular tool call, but I have not allowed it in the permissions, in the settings searches. So it is a judgment call. If you made it well, the system feel alive. If you made it bad, it will fall apart at seams at the very edge cases. So what happens if your latent space is more and you don't have deterministic space or the deterministic controls? What happens is it is a classic case of hallucination. It will give you outputs. They will look right, but when you will sit and check them and reason with the agent, you will see, there's a temporal hallucination or did a correlation hallucination, or this does not fit well, etc. Because the model is hallucinating. You don't have the right deterministic space or just checks to ensure that you are nudging the model in the right direction. If your deterministic space is too much, it is like your traditional code base, as we discussed. If you have a DAG with some scripts in between LLM calls, the agent does not really have the control or ownership over the outcomes, right? Because that is being controlled by a code. So you will feel like it's dumb. It's not that intelligent. It's not taking the ownership. It does not have the agency, right? So depending on in what direction your system is drifting, try to check as a very fundamental decision, where is the point at where you have assigned more weight and where you need to shift more weight in your system that you're building. It's a simple problem like this seating chart problem, right? To give an example, that if I ask an LLM that, okay, this is the room capacity and I have just 8 people to sit, works, it will tell me. If I have 800 people, it will give me plausible looking nonsense, right? The space constraints, time constraints, how it will scale, the people will come, how will you fit the people. It will give you plausible looking nonsense. We don't need to use LLM for this particular use case, or if so, it needs to be in the right mix, right? So what is the right decision? The model invents themes, like what are these seeding patterns that we can use, and then it uses already existing algorithms to assign seeds to those people. So this was the first part of our discussion. Is even before we discuss how we build multi-agentic systems and how you can use them in cybersecurity and all of that. This is the first fundamental principle that you understand what really is an agent. What is the difference between an agent and a workflow? How do you boil down to the first principles of how an agent should work, and if your agentic system is not working, what exactly you should think in which direction. So this was the first part of it. Do we have any questions as of now? Then we'll move forward to the agent SDK.
There are some questions in the chat. If you
Wait, check. Can agentic be replaced for components like SOAR, N8, etc., or complement it? Okay, this is Warren. Okay, I think these are
That's
introductions.
the only question. That's the only question for now.
Okay, so good question, Lionel. What it basically means is, see, SOAR, N8, etc. First of all, SOAR is uh, so all of these three things are different. N8 is exactly it is one of the, I will say, older frameworks to how you build autonomous systems, uh, which is very different than SOAR. And agentic systems are it is see of it as a underlying concept, right? Think of it as you know as a basic underlying layer, like we discuss of ChatGPT or LLM. Like we can use LLM for any given use case or in any direction that you want to achieve. So we discussed of the concept of agency, right? That the system is taking the ownership of outcomes. So that is what we are trying to build here. Now you can implement it for SOAR, for SIEM, for MDR, for CTEM, whatever use case that you want to implement it for. Now, N8 is the one of the older frameworks to build the autonomous systems, and really in 2026, I personally don't recommend you using N8, but it is an entirely different category of suits than the SOAR, SIM, CTEM stuff. I hope that answers your question. Mazdad, you are on mute.
Yeah, there is one more question from Vishal. How do we gonna handle the hallucination part while agent working on a target?
Yeah, we'll come to that. I think the first fundamental principle that we discuss is boil it down to this principle that whether you have the right balance between your latent space and deterministic space, in whatever agentic system that you're building, right? How exactly you can do it in the Claude Agent SDK, the framework or whatever framework that you're using, we'll come to that. Yeah, Alan, I will share these slides with Mazdar, so you can have them.
That's all. I guess you can move forward. Those were some of the only questions.
Yeah, cool. And guys, you can unmute yourself and interact if you have any follow-up questions for these. If you understood, if you have any doubts further on the explanation that I gave. So feel free. Okay, so I think nobody needs a slide of what exactly is Claude Code, but just in case. Uh, So there are three things here, right? One is that the very fundamentals. It is a CLI agent. What it means is that it's not a chatbot. It is not an API wrapper. It is an autonomous agent that Anthropic has built, which has access to a predefined fundamental set of tools that it uses to explore the context, gather the context, and take actions. Uh, what it does is that for context, it reads Markdown. And then obviously, as we saw, what really is an agent and what is not an agent, it thinks and then it acts, right? So it is one of the agentic systems that are built by Anthropic in the market, one of the best in the enterprise market as of now. Cool. So what we will look as of now is what are the building blocks of uh, building these multi-agentic systems, right? And then we will look at the multi-agentic systems and what are the patterns that you can use to build them. Okay, so let's start with the building blocks. The very first is your tools, right? The deterministic substrate. So what I will do is, as we go through these explanations, I will correlate these things to this thing, right? And I would request you to do the same as you brainstorm. What I'm saying is correlate this thing to this balance. That whatever I explain you in the framework and how you do it, where it sits right here, where it sits in the latent space or in the deterministic space. So the first thing is tools, the deterministic substrate. If I want to check what are the repositories that are there in my GitHub, the model does not need the there's no function of latent space there, right? I can write a function which does that. If I want to query a database, I need not to do that. Just by using the latent space. I can have deterministic scripts that are attached to my LLM. So what are tools essentially is they are deterministic piece of codes that your LLM can see what it is doing and call it when required. Right. So that is what you define as a tool. So if I'm, hammering a nail, right, I use a hammer. What is a hammer? It is a tool. So what I do, I pick the hammer and then I nail it down. So what the only when I need, right? Like I do not just keep, a hammer in my pocket all the time. Similarly, think of the model as a brain, right? So if it makes a decision that, okay, I need to see what's in the database, let's say I'm, making my own cybersecurity newsletter, or Mazdad is making his own sci-fi newsletter so that people can come and see what's going on in sci-fi community. And he's building an agent for it. And let's say he's using ClickHouse for uh, storing the newsletter JSON that he is wants to present on the website, sci-fi website. And what it has he has some context of whatever going on is in sci-fi, and he wants, hey, based on this context, the go ahead and write a newsletter. So if the agent wants to say, hey, when did I issue this newsletter last time? What it will do is that it will use the ClickHouse CLI, check what was the last issue that was done, what I did there, gather that context, and that is the what is the function of a tool is. Right? So if we see in Claude Code, this number gets updated very frequently, but the fundamental of operations, if they have built them in the uh, form of tools. Why did I say fundamental operations? Is that when you are building these multi-agent systems, please take care of, even though you are building it for a given domain, the right starting point is that you need to just switch the context and it shall work. If not, let's say you build a multi-agent system that is 90% there of your expectations of taking the ownership, right? Always benchmark it against ownership, as we have discussed, right? I'm stressing on this point again and again. Is the uh, the very fundamental fact here is that you need not to worry about what's going on, right? That's the very fundamental thing of it. So uh, whenever you're building a multi-agent system that takes the ownership, and let's say in cybersecurity it is 90% there, what you need to take care of is it shall be generalized, right? What do you mean by generalized is that I switch the knowledge based on context, and if not 90%, it shall work 60% there, especially in the case if you are building a generic multi-agentic system. And even so, in this use case specific ones, is that use case specific ones or domain specific ones as well, because what it allows you is that to do is that you have a generic set of tool capabilities that you have that you can use. Right? What do you mean here is that if I build the tools around too much around a very specific use case, right? My tool size will grow, right? Let's say if I have a tool for checking the number of repositories, then I have a tool for checking the ownership of those repositories, and then I have a tool for managing uh, what are the access controls that I have in my GitHub organization, etc. Right. So that is bad code, right? I think all of us have been through, especially the experienced cybersecurity professionals here, is that is just bad code. So bad code is bad code everywhere. Doesn't matter if it's attach it with an agent. If it is not generalized, it will cause you problems. So what Anthropic has done here is that if you see the list of tools in the documentation, what Anthropic has attached to the agent, it has attached a very generic set of tools. It has not like tool calls like understand the intent or uh, very specific uh, uh, tool implementation to do a specific task. They have connectors for it, right? Like I have a Slack connector, I have a GitHub connector, etc. But the agent at the fundamental level has fundamental tools like read, write, edit, glob, grab, dash, task, web fetch, web search, to do write, right? Notebook edit. All of it are fundamental tools that it has given to it. So that whatever you throw at the agent, it is able to do it without figuring out, without going through, let's say, 100 tools and figuring out what I need to do and all of it. So this is the first building block, and it lies at the deterministic substrate or the deterministic part of it. Second is skills, right? How many of you have already worked with skills? Anyone in the chat? Okay, Devesh is there. Mohit. Okay. Okay, looks like we have a couple of folks that have worked. Cool. So for those who have worked, let's go through it together again. I'm sure you will find something useful out of it and you will have a fresh look on how you build skills yourself. So what skills are is that they lie at the latent space side of it. Skills are nothing but markdown files, but built in a way that the agents can go through them easily. So before I go through the skills, sub-agents, hooks, MCP, all of it, I would like to introduce some concept to you. Is that when we have started using these AI for coding, right? The very fundamental thing that you need to take in your mind is that how you're positioning a code base and for what. What do you mean by that? Is that since all of us, if not in RAS mode, we are at least using AI assisted programming, and the AI is going through your code base, trying to understand your code base and make some sense out of it and do some implementation on top of it. The shift that AI has brought is that after AI, you have to write a code in such a way that it is easier for the AI to look at it from a fresh eyes. Right. So essentially, you're writing the code base for the agent so that it can do whatever it wants to do with it without having trouble. One of the classic examples to look at it is that whenever, let's say, you ask Claude Code to write a file, you must have seen it rise very verbose comments everywhere, right? In the doc strings, in the comments, everywhere it writes very long descriptions and long iterations of what you stated, even though you have a documentation. Until and unless you have stated it, don't write it. By default, it will do it. Why is it so? Is that it has been baked into its behavior that if an agent is working on a code base, it has to write that in such a way that if a fresh agent starts without any context of what the previous agent did, it is able to go through that code base and figure out what's what. Right. So whenever you write a code base, whatever you're building, right, with the AI, build it in such a way is that it is easy for your eyes of your agents to see, to look at what's what. Right. So that is a guiding principle that you should use while building these systems. And similarly, these skills have been uh, created. Right. So if we really look at it, this skills thing, why is Claude Code so popular? I would like to ask you guys this question. I've already given that hint, but I would like to ask you guys, why is Claude Code so popular? There we have, dozens of multi-agentic systems out there. What is the reason behind the success of Claude Code? Um, you can, note yourself and speak or write it down in the chat, however you like.
It's harness.
Yeah, Samir, you broke off, looks like. Shashank, I didn't get your point, like what you were saying no to. Can clarify the quality of the data that AI was trained on. So, see, the difference is that, yeah, that is the right point, but the session is wrong. The session is right, the reasoning is wrong. That the models are right. So, we need, as explained, there's a distinction between an agent and the LLM. Agent is LLM plus harness. If you dumb it down, it is LLM plus harness, right? So Claude Code is an agent. It is not a model. Accuracy and limited hallucinations. Yeah, but what is the reasoning behind it? We know that the quality is good. It does a good job, but why? It's for skill set. Uh, Sorry, I didn't get your question, Shashank. If you can please write it a bit more in detail, or you can speak it out as well. Why is it so good? Why is Claude Code so good?
Maybe because it's like modularizing all the skills, how the agents interact, and also giving a guideline. So it is very modular in the way it tries to execute things. So probably that is the reason.
Okay, okay, yeah. Um, any other thoughts? Anyone? Okay. So for if AI or model is trained on poor data, it may not be efficient and give poor results. Yeah, you are right. As I said, the agent is LLM plus harness. So if the LLM is bad, it's bad. But we are talking about the harness. Let's say you are allowed to switch whatever model you want to plug in and out. I think there's something on open Claude Code as well, right? So you can see this open Claude thing, right? So what I'm discussing here is that at the harness level is what what Centropic guys have done good when they were implementing deep learning and self-learning ability to improvise. Self-learning will doubt that self-learning is not there as of now. In the I will say the vanilla Claude Code, a good dynamic runtime execution. But yeah, what is the reasoning for it? So I think Sachit highlighted it right, is that it has a good distinction between the tool calls and the context, right? So when Anthropic released this, I think around later half last year, third quarter, I think November 2025 or something like that. Uh, Around the same time frame, what they release is what they released MCP, and also they released this notion of skills, subagents, the .Claude folder, how you manage this context and all, and separation of concerns, right? So the same guiding principle, right? Right, the separation of concerns is that you are separating the concern of how the context is managed and how you can edit it and express it, versus how the tool calls are operating, and what is the link between the two. So if you see the the first agentic frameworks that came out, what you need to do is you need to write an agent object and then assign some tool calls to the agent object, and then that agent object is reading the tool descriptions, making a judgment, and then we are calling those functions with the parameters that the LLM has assigned. It gives the some output that we are feeding back to the agent as context, right? And the harness that builds on top of it. But this was the fundamental principle of the first age of the agentic frameworks that came. Now, do you see the problem here? The problem here is that, okay, it's not just an LLM call, but it is a sophisticated LLM calls. But still, the principle of dynamic execution flow at runtime is not being obeyed. Why? Because still you are creating an agent object that has access to limited set of tools using which you are doing some task, right? So the agent is constrained by the quality and the quantity and the intent of the tools that you have given to it, right? And the context that you're passing in the system found in the files that we're attaching with the agent. What they did good is, if I'm an FD, right, when I say a forward deployed engineer, although it is a different segue, I will take questions regarding that, how to be an FD and all of it. But as an FD, if I want to do some change in the business logic, previously I have this of sophisticated agent classes, and then I can declaring an agent object, and hey, here is the context for this particular agent. Go edit that, and you know what, this agent needs this tool. That's why it's failing, and then I go and attach that tool, and then the communication between these agents are failing. This is way back when the agent-to-agent protocol by Google was not there, or city was not there. So it felt like a bit of a mess for me, and that's why it looked like all of it is this spaghetti code where I'm not able to figure out what's going on. Um, what we have done, as I said, is good separation of concerns. Is that all of the business logic, the intent is right in the form of the markdown files, right? And what I do is Claude -p on top of it. Not exactly that, but very much that. And the agent, using the fundamental set of tools that are baked in into the framework itself, it is able to catch that context, understand that context, and do some actions on top of it. So as such, it said, it is that they have right, they have segregated things properly, that have different skill files, and what the agent is doing is independent of what I'm doing in the skill files. Right. So that was the fundamental principle. Any doubts here on this question? No, I don't think so. So that was the distinction, right? So similarly, the same principle, as I said, the separation of concerns, same we are using in skills, right? So skills are basically markdown files, but there is a way of writing it, right? People say that, hey, we have 1 million context windows now, and we don't need these tools to write skill files, and I will write whatever, and it will just work. No, it's not like that. Especially, it will fall apart at seams, as I said here, right? As I mentioned here. If you not have the right deterministic space and controls, it will fall apart at seams. What do you mean by that? When you build a large enough multi-agent system that is handling real production data, and you want to take the ownership, if you have not defined your skills the proper way, it will fall apart. It will not be understand when to use what and how, and go hallucinate. So then there are about, I would say, 10, 12 principles that you need to take care of mine, like degrees of freedom, the anti, how you have mentioned, the anti patterns, what is your prompting technique, and all of it. But fundamental things are just three. First thing is the front matter. Front matter is whenever, let's say, you have a .Claude folder, right? inside that, for the ones that you have used it, I have a skills folder. And inside this skills folder, I have these markdown files of skill.md. Right? Now, what Claude does is that it does not goes and reads the entire .claude at once. It reads just the YAML front matter, is what this skill is for, and when do I use it, and what are the allowed tools if you have mentioned it there. So take this analogy. The same analogy I did before is I just know that I will pick a hammer or I use a hammer when I'm nailing something down, right? Nailing a nail down. Uh, so that's what all I know. Like I don't know which wood of that hammer was made of. That's what I don't want to know. But I don't want to know all of the intricate details of what size of nails I have and all of it. I just know that okay, this is what a hammer, this is what it does, and I will come go use it whenever I want it. Right? That's what I store in my mind. Similarly, in Claude, you have a main Claude agent that has the target and the some context that you have defined, and you have to use the tools that it has to achieve that outcome, right? So what it does is that it just reads the YAML front matter and decides on the basis of that when I need to use that particular skill. Now I have just let's say written some in some gibberish language that what this skill does that like Claude answers us in broken phrases and overly expressed jargon. If you apply the same thing to Claude, the funny part is that it will not understand. So description is essentially how well you have defined when to use what. Right. So take care of that. Check your descriptions. If you feel like, hey, why didn't you use a skill? I created a skill. Why is it not using it? Check your description. Check your YAML front matter. Have you allowed the right set of tools? Right. Second thing is the body. Right. So markdown methodology. What do you mean by markdown methodology? Is that hey, please go do that. Right. Don't write that. Right. Have a proper anti-pattern section, and in the anti-pattern section, properly list out this is what explicitly you're gonna have to do, right? And then constrain it by the allowed tools that you have. For example, people say, hey, you know what? The Claude Code deleted my production database. Why did you allow it to do it, right? When it is doing a right action, why do you have given it the permission to do a right action? Before doing a right delete action or a right action, why it is not asking you before it is doing that? So mention the anti-patterns problem. What are the degrees of freedom? What are the thought constraints in which you can think where you're allowed to go, where you're not allowed to go, right? What is the intent? Right? Have a proper intent section. That what exactly I'm trying to get out of this skill, without telling how it happens and all of it. Uh, have an intent section. So try reading a recipe. Right, a recipe is a very good analogy. If I want to make kadai paneer, right, what is there in the top is that this recipe is for kadai paneer. These are the ingredients that you require. These are the steps that you need to follow. Once you have made the kadai paneer, check how much salt is there, right? Whether the spices are right or not, right? All of that. This is all a recipe is, right? Similarly, skills are the recipes for the agent that you are building to do what it wants to do, right? Uh, Here, the length of it, keep it below 500 lines of your, uh, when you see the LOC of your skill.md, keep it below 500 lines. 450 is good. I will not say you go to the extent of it, even though it has 1 million tokens, because then you don't have a good separation of concerns. And uh, from separation of concerns, third thing is references, right? So if I have skills, let's say for authentication testing, I have a skill.md, and after that, shall have helper scripts and references. So references are, hey, just in case you want to know more about this, go read it here, right? So for example, Slack has an AI bot, right? Now, if I'm using Slack for getting the updates from my agent, do I need to know what Slack AI bot is doing? No, I don't need to know that. I need to just know how you can use the Slack MCP to write a message, when to use it, etc. Whatever the auxiliary knowledge is, that hey, just in case you need it, go read it there. Put that in references, right? So this is the principle of progressive disclosure, right? Progressive disclosure is that in the front matter itself, you have properly, clearly defined, okay, it is what it is, and here is how you need to use it. Then you tell it, okay, this is how you need to do it, and then you tell it all of the extra stuff that you put in the references. So make sure that you have this principle of progressive disclosure obeyed in your skill.mds that you create. Next thing is subagents. Subagents are also skill.mds, but the thing is that they operate in the isolated context environment. Think of them as a sous chefs in the kitchen. What does that exactly mean is that whenever I'm trying to, uh, you know, do some isolated task, like for example, I need, let's take the example of Mazdad building the newsletter for sci-fi community, right? Mazdad needs to do deep research of what are the other cybersecurity companies doing, right? Or and also it needs to check what are the good newsletter designs. I need to do a bento grid or it shall be a carousel on the website, right? Uh, Similarly has let's say 5 tasks, right? And all of these are mutually independent. I need not to worry about what the competitors are doing, just to figure out what is a good bento grid design. So there, what we do is that, as I said, in Claude, we have a main Claude agent that is running and using the tools. What it does is that if you have predefined these subagents, it dispatches these subagents, and these subagents operate in an isolated context environment. What do you mean by that? Is that they don't have a running context knowledge of what your original Claude was doing in the session. So what do you mean by that is, whenever you're in Claude, tells you a dial in Claude Desktop or in the REPL mode as well. It tells you how much context limit has been reached, right? But what happens in subagent is that the subagent execute and then you inject that particular context to the subject. Hey, this is what you need to do, and this is how you do that, and return back the output to the main Claude agent. Right. So imagine like a sous chef, right? If I'm cutting uh, vegetables, then the sous chef is focusing on how do I cut that specific vegetable. They're not worrying about what is going on, what the master chef is doing, or what other sous chefs are doing. Right. My task is cut vegetables. I'm cutting the vegetables. So they have specialization. Right. They operate parallel and they operate in isolation. Right. Next thing is hooks. Right. So these two things were on the latent side of it, and hooks were on the deterministic side of it. What are hooks? Hooks are basically deterministic scripts that are attached to lifecycle events in your Claude session. So whenever you use Claude, it has a lifecycle to it, right? What I mean by lifecycle is that the session starts, the skills execute, the agents execute, the main agent verifies the output, checks whether it is done or not, session ends, right? Now, all of this, there are lifecycle events. What are these lifecycle events I'm talking about? As I was mentioned, pre-tool use, post-tool use prompt submit, stop, which is the end of the life cycle, or session start, or session end hook, uh, post skill use, right? Uh, all of these are life cycle events. So what happens is, let's say I have a workflow. Say an example, building a newsletter for sci-fi community. I have these steps, like do the research, then write a plan, and then mail it to Mazda, right? So it has a workflow to it. And after each of these steps that are there in the workflow that I mentioned in my Claude.md, I need to execute some checks, deterministic checks that are specific to that workflow that I have defined, right? There are generic hooks as well. For example, you can have a generic hook for checking if the environment variables are loaded or not that your Claude wants. So it can be a generic hook. It can be a workflow specific hook as well. For example, the deep research has these sections or not. Every time Microsoft wants to do a deep research. So these are the deterministic guardrails. So we said it as a piece of code that execute at a session lifecycle event. Right? So uh, as we are going through this, we must be able to see how Anthropic has balanced that latent space and deterministic space. Third thing is MCP. Think of it like trucks. Like let's say I want 100 carrots for my next thing that I'm cooking in my kitchen, then I a truck comes with all of that supplies, right? So think of it like that, right? Model context MCPs that we use, it is a protocol, but the MCP connectors that we use, they are basically a productivity engineering and custom based, right? I can build my custom MCPs as well. So what do you exactly mean is that when we go to the first generation of agents, when we discuss about that agent object and all of it itself, you must have noticed that when I'm attaching those tool calls uh, to that agent, I need to write those tool calls, right? Obviously, because it is a piece of code of the agentic system that I'm building. Now, there are two organizations, both of them are trying to list the repositories in my organization, check the access controls, uh, who has and what commits and at what time. All of it, the intent is that all of them, both of them are trying to do the same thing, right? But now at that point of time, both of them are implementing separately. They have their own tools, files, and all of it, right? What eventually shall happen is that Slack, GitHub, Microsoft Teams, Form, uh, all all of these service providers shall have their MCPs and their tool calls that they allow and all of it. And I connect to those MCPs and get what I want, you know, from a fundamental set of list calls. Basically, where basically in most of the cases which I get is just list those call tool, get the output. So I need not to. The point is, I need not to manage what these tools are doing, right? In order to uh, uh, see what or get the output out, right? So what do you exactly mean by that? The same thing, separation of concern. I don't want to maintain a piece of code that ideally GitHub shall be providing me to talk to my agent, right? So that is the productivity part of it, right? So we have MCP, so Gmail, Drive, Slack, Notion, etc. So you just create an MCP client and connect to the MCP server by the provider, and then it gives you an excess of the set of operations that you can do, right, without me writing the tools myself. Now, if you see what the stuff that we're discussing here, why Claude Code is so good, is this principle is thin harness and fat skills. So what you do is that the harness is skill, it has some predefined set of tools that you can use. So it has a limit to it, but the context management shall be good. You have probably, mentioned what is the intent, how you include judgment, what is the methodology, what are the anti-patterns. All of that shall be properly described, right? And the tools, the administrator tools, they shall be try to make them generic so that you don't end up switching your tools every time when your agent hallucinates. Right. So this was the second part of it. Do you have any questions here before we move on to the last part, which is the multi-agentic systems, and then we will move on to the demo.
There's one question from Mohammad Adil. Is Claude Code restrict cyber security thing like BB hunting?
So what happened is because all of the incidents that I showed you, and probably it is my personal opinion, it's probably because of marketing as well. Uh, because of all of the multitude of reasons, what happens is that Claude Code restricts you doing not just cybersecurity operations, but if you're trying to train your model or LM of your own. So, what they have mentioned in, if you see the latest model releases, I think there's some notice that they release, something like that, where they mention is that the model will give you dumb output if you try to train a LM using Claude, right? Because you don't want to build their competitors. That's what my assumption is, but it will not even tell you that I will not do that. In cybersecurity, at least I've observed it that for penetration testing or black box hunting or for any cybersecurity operation, it tells you, hey, I cannot do that. You need to be a partner. But yeah, there are certain areas where you cannot use Claude Code. That's what happened here, right? When I was saying this, when this incident happened with Anthropic here, sorry, with Hugging Face, uh, they were using open source LLMs running on their on premises, running on their on-prem, right? All of these hosted providers denied than the XL. Right? So zero usage policy is binding the attacker. Right? The attacker is doing whatever they want, but for the user, you have all of these usage policies. You can use Anthropic cybersecurity skills for pen testing. Uh, as I said, that is with counterintuitive on their side that you're not uh, allowing Claude Code to do cybersecurity, but they're using skills. But that is because the stuff exists out of it. So what Anthropic wants is the model part of it and the harness that they did. Now, since people have used that harness and decoded how it is working, they have built stuff like this, like OpenCloud, right? There's the harness part of it, and you plug in your model, whatever model you want to use, right? So for people who are not using Claude Code, they can use their skills with whatever harness or model that they're using. If you use a Kimi fan or your deep seek fan, then still you can use their skills. Table model closely restricts and switchbacks to opus when we are cybersecurity things, right? That's what I was saying. How we can create own customized skills. I will show you how we have done that. It is just marked on files. I will show you that thing. We'll come to that. Any other questions? I think we're good to proceed. Okay. So I will give you this guide with a pinch of salt. Whatever I have given here, mentioned here in these patterns, especially this particular part of how you build multi-agentic systems, is what I have accumulated over my experience of building multi-agentic systems. And you might or might not find these concepts uh, uh, somewhere else because these are the abstractions that I have built on top of studying what Anthropic has done, what Google has done, what OpenAI has done. How do you categorize them? What are the new ideas that are coming on, even on Twitter? What are the emerging approaches that are coming? And I have accumulated that here for you so that you have a 50,000 foot level view of what needs to be done, how to manage multi-agentic systems. Right? So one thing as you must have been noticing, that is repeating again and again, is separation of concerns. Right? And for the same reason, we need multi-agentic systems as well. Right? So I think one of you guys mentioned how is it different from SOAR. So SOAR is a use case, right? That is the product that I'm building. How do I build an agentic pen testing or an agentic SOAR? The right answer is you build a multi-agentic system for that SOAR, right? Uh, because the set of tasks that I need to do in whatever use case that I pick, they are of there's so much and there's so much ownership that needs to be divided that a single agent, I will not say cannot do it, depends on your use case, but it's not ideal to use it because a lot of context management is required. So let me simplify it. What does that mean? So in each of these organizations we have teams, right? We have teams for cybersecurity, for offensive, defensive, compliance, vulnerability management team, threat intel team. Why do we have those teams, right? I can have a small team that does everything. That's what actually happening with Claude. Uh, but why do I need that hierarchy, that design of the organization? Is that even though a person can know how to do threat intel and pen testing at the same time, I don't want that person to do both things at the same time because of separation of concerns, right? The better the separation of concern or the distribution of the task that needs to be accomplished to get an overarching goal, that needs to be divided in such a way is that it is easier for the fundamental units that are working on it to manage it, right? Fundamental units in organizations are humans, and when we're building a multi-entity system, they are agents, right? So that is the intent behind it, right? Now, when we start with this question, okay, so fine, we are building something big enough and we need a multi-agentic system. Good. Now, What are the next set of questions that come in mind? What set of agents to begin with? How do you even start with? What is the environment? How do I configure it? And these are so many agents. How will they communicate with each other? How will they work? Right? All of those sort of questions. So these were the stuff that we discussed just now. That for context management, for spatialization, so that the teams can execute in parallel. This is proper isolation and separation of concerns. Because all of these reasons, we need the agent. That's why I did the Claude is screaming, bang my team. So we'll go through these patterns one by one. That how do you build these agents? See, at the implementation level, we'll come to it. We'll do a demo. I will show you a penetration testing agent that we have built, and it is in top 25 on Hackthebox. So in the Hackthebox leaderboard, it has solved various fortresses and challenges, and it is in top 25 in the world, right? And it learned its way through it. So I think 8 2 months back, it had around 800 900 rank, and we built it in such a way that it was learning on its own the exploit techniques, when to do what is what, right? It did it itself, it upskilled itself, and then uh, it is now in top 25 on Hyderabad. So we'll come to that. How do you build a system like that? Uh, what are the principles? What is the exact implementation? But think of it at this level, right? Now we're coming at from 50,000 foot level to 25,000 foot level. Right? We have these agents, right? I have 5 agents. Imagine it as a team. Now, how do you organize them to achieve an overarching objective? Right? That is the prompt. We have 4 patterns here of mass orchestration or multi-agentic system orchestration. First one is agent-based, as in from an agent perspective, how do you uh, define the relationships between the agent? And second is state-based. State-based as in when you're going through that workflow, how the communication is happening, what is the control, like as you're passing through, how is the context being transferred, right? We can divide it into these broad 2 categories, and I will put in all of the frameworks that we have in uh, these 2 broader categories. First one is agent based. So what do you mean by agent based is that there is a fixed plan at the start. Okay, this is what needs to be done, and then at the runtime, the agents are making decisions of what needs to be done, and then passing the information from a starting point to an ending point, right? So even though their individual executions are independent of how they're doing the task, they know what exactly needs to be communicated and achieved. So there's a fixed plan to it, right? So they have a start node and have an end. Now, uh, it is not a DAG, right? Because what happens in DAG is that the individual operations that are going through this inside those nodes are non-agentic, right? In this case, they are agentic. Second is a dynamic flow. So exactly happens here is that the agent level of agency increases here. That I'm on an exploration mode. That I have an objective, and then the start nodes compute something, and when it feels it is done, it has a set of options that it needs to do, and based on the exploration target as how it is changing, it picks the right agent to use, and then calls that particular agent, and then that agent does something. So this is a typical workflow for building a penetration testing enthusiasts that are here. So building a penetration testing agent, what it needs to do is that you cannot have predefined thing for if this that do this that if you call hey you do this and you call this agent, because it really depends on what kind of exploit that you're trying to doing, what you're doing an backend test or front end test, or you're trying to do an authentication bypass, what exactly you're trying to do, right? So it has to be a dynamic flow. But if I'm doing a deep research, it has a fundamental steps to it that understand the objective, do the research, write down what you have researched, synthesize it, put it into a report, right? So I have a flow to it, and then inside all of these actions, that how research happens, how synthesis happens, how report writing happens, how intent understanding happens. That is I have left to my independent agents to figure out. So it was on the basis of agent, right? How the information is flowing from an agent to an agent. Second is state based, like how the context is being managed. So one is this peer-to-peer network where all of the agents are communicating with each other, and what happens here is that they arrive at a consensus when all of them are satisfied. Right? So it is a classical peer-to-peer network. And second one is two-way graph traversal. What happens in two-way graph traversal is that I have an origin, right? Uh, from where the all thing starts, and then at runtime, all of these agents are trying to communicate with each other back and forth, arrive at an output, and then once an agent uh, achieves the goal, it returns back to origin. Imagine it as that you are trying to build a football team of agents that is trying to score a goal, right? You know, hard code, the Messi agent will do the goal, or the Mbappe agent will go do the goal, right? You cannot hard code that, right? It depends on how the defenders are positioned, how you're doing the passes, right? All of it, right? So you cannot define it, and there might be passing back and forth for some time just because the situation is not right, right? So that is the another way of flowing the state between the agents, right? We are trying to build some football agents that uh, beats everything in the World Cup. So these are the uh, patterns. The best practice, I think I've been covering that throughout the session, but the tools are just in substrate, use LAMP tools and MCPs and hooks as the domestic part of it. In this case, use when you have a recipe, sort of, right? You have prepared a methodology. And sub-agents are basically your sous chefs, right? So sub-agents are like having a thing that gets thing done, a very specific thing done. And skill is more like the knowledge that how a specific thing needs to be done, right? It is about how, and sub-agents are about more about what, right? So that is the fundamental distinction. Context is the real bottleneck. You know, we can have another session of 90 minutes long about how memory management needs to happen. But at the very fundamental level, make sure that the compaction happens. If you're let's say you're done with the task, try to compact it. Otherwise, Claude automatically does that. Third thing is prefix caching and prompt caching. So based on a use case, see, how long you want to make a context layer. On the basis of that, do prompt caching. Right? Third thing is resolvers and on-demand loading. This is again the progressive disclosure principle. Right? So if you have, let's say, 1,500 lines in your markdown, right? That's not a good slot.md. It needs to have progressive disclosure. That okay, this is what exactly needs to do. That is what Claude.md is. That is your objective. For example, in penetration testing, you are a penetration testing engineer. Right? That's what you mentioned in Claude.md. You do not mention how an authentication bypass shall happen in Claude.md. That is a skill. That is a recipe. Right? How you do not mention how to do SSRF. That is a skill. That is a recipe. That is not the intent. Right? So it keep it crisp and surgical, right? And make sure the progressive disclosure and the separation of concerns is right. And from deterministic point of view, these are the evals that you can have. One is task success evals, that is whether a tool calls are right or not. Trajectory evals, as in this communication that we're discussing here, that is being followed or not. Tool use correctness, verifier patterns. Verifier patterns that at the end of your workflow, before the agent marks that the goal state has been achieved, you how do you verify deterministically that whether it is really done or not? Right? Cost and latency budgets, right? So check, how the communication happening. Can you switch the architecture, right? Or how much costs that are being incurring based on what we get from these cost and latency budgets. Regression tests, right? So this is very important. And adversarial tests. These are very important, right? There's sometimes discussing that, hey, Claude went ahead and deleted my production database or changed something and it made a spaghetti code. Is that you don't have these 0.6 and 7s? Is that why you are giving the agent a right access in your production database? Right? If you are giving it, then engineer in such a way that that is coherent. It messages you there's a protocol to it, right? That are what adversarial tests are, right? Someone is not doing your what if the user for which you're building a multi-agentic system goes ahead and tries to do prompt poisoning, right? It tries to make the agent do something that is not intended to be done. How do you handle that? Right? Make sure you have implemented all of these 7 events whenever you build enterprise multi-tenant system. So it's demo time, but before we see the community tools that we have built, how we have built that multi-tenant system, how do we really organize all of these skills? Do you have any questions here? Yeah, as I said, we will have the demo. From pen testing point of view, how do you control what the agent is allowed to do autonomously? What shall do by human to approve first? How would a custom harness help us in control this? Yeah, I will show you community tools and what happens here. So at Transilience, our team has been working on this community tools. This is the same agent that I mentioned that is in top 25 on Hack the Box. And using the same agent, what I will do is I will walk you guys through uh, the very steps of it and how it is processing and also the framework, right? So I'm just coming to this part, but do you have any questions regarding what we discussed? Is there a way to calculate the tokens that would be used? Yeah. So so Claude has this thing called flow.json. So you can always get that from the framework. I'm trying to find a few session notes. Yeah, I think it's a bit extended, but I think we'll take 5 more minutes or so. 10 minutes or so for the presentation. Uh, any other questions that we have? Yeah. Okay, I think we can proceed. So I hope my screen is visible to you all. So what community tools is that they built a monolithic agent that has access to uh, uh, skills, and it is able to do various types of operations and penetration testing. Like, so here is a detailed list of people want to do and prompt injection, client side tests, server side tests, authentication, API security, system tests, infrastructure tests, social engineering tests, right? Reconnaissance, platform integrations, tooling. So all of these are capabilities of what you can do here. If we see, if we go at the .claude folder, if you see here, we have these skills here. Now, if you see these skills, they are grouped by the project disclosure concept that we're discussing. That I have skills for authentication, and then inside that, I have a skill.md, and whatever additional reference is there, that is in the reference folder, right? So you see, there's a whole lot of context that the agent needs you. How do you do capture bypass, what detection, all of it. But that is in the reference. In skill.md, there is a YAML front matter with the name and what it does, right? Like, for example, it explicitly states that it can do auth bypass, UWD attacks, OAuth flows, password attacks, etc. Right? And then it tells, you can see it is pretty short, right? What is the workflow? What are the references? What are the tools? What are the techniques that you can use? What is the intent? Right? Pretty short. And then out of the specific thing that you want to do, the Claude will come to this skill, and from here it will go to these references and see what are the authentication principles, what are the resources, all of that. Similarly, we have for Hack the Box as well, we have the skill. How do you autonomously go and solve Hack the Box challenges? So it actually does this. We have a Slack channel where it gives us a report. Like, we have this Slack channel and that plan test. It tells us, hey, I found this. This is the progress update that I've done. All of these are agent messages. And hey, I did this. And it upskilled itself over time. So I will point you guys there over the skill thing, but these are the auto skilling part of it. That it has this skill creation, update, and management skill that we have created, right? So it is the self-learning part of it. In 2026, as we are in the second half moving on 2027, one of the fundamental distinctions that you can do in multi-agent systems is that you can have the self-learning capabilities in your agent that is able to upskill itself and use that upskilling to achieve an output which was not able to achieve earlier. So we have these skills. You can check this out of how do you automatically update your skills, what are the principles for that, etc. Right. So I will do a quick demo of a port trigger lab that I have identified. So what we'll do is username enumeration via different responses on port trigger. So the problem statement here is that I have username and passwords, but I don't have an exact match of what is username, what is the password. I need to decode what the oracle is, and then based on the oracle, I need to sign in as a user. So I have this blog page, and it is not solved as of now, right? So what I will do is I will just open the agent and ask it to authenticate here, given the data that's given by port trigger, and let's see what it does. Let me zoom in a bit for you guys. Okay, we are on main. Okay, so I've started my Claude here. And since we have this .Claude folder at the root, very important is that wherever you start your Claude, right? If you want to make sure that you're using whatever skills agency are defined, make sure that you start your agent where it has at the same level as where your .Claude folder is, right? So that it knows what is the Claude remedy. Uh, if it is a global Claude remedy, that will know it. But if it's project specific, make sure you start at the right point. Now, what we will do is I will not tell it anything. The intent of the multi-agent system is that when you build a multi-agent system, you want it to test its ownership, right? As you were saying. So the right way of it is just to tell it, hey, go do this, and it shall be able to figure out what, why, how, and come up with the route output, right? So I will just say solve this, and let's see what it does. Meanwhile, it does this. I hope I don't get blocked by Claude. It is an intentional. I have chosen a easier exercise because of both of the reasons, right? Claude flags it, and also for the lack of time, because these exercises can go on for 45 minutes, 1 hour, 4 hours, 6 hours. This skill can be used in Claude only. No. So that's what I was trying to emphasize here, right? That there are open harnesses like OpenCloud, right? So you can use whatever model you use with this harness. So agent is harness plus LLM. Now LLM, you can use any LLM that you want to use. LLM provider, DeepSeek, Kimi, Anthropic, OpenAI, the open source LLMs OpenAI release, or the Neutron by NVIDIA, whatever you want to use. And with this, you can use this harness with this harness, right? And there are multiple harnesses like that. We have Hermes, right? Somebody asked that the self-learning capability. So Hermes has that self-learning capability. Hermes GitHub, this one. So it has the self-learning capability. You can just run the harness, right? Using the same Claude code based structure. The multiple harnesses like this. And then we have the famous OpenClaw, right? So all of these are harnesses, and then you can use this with whatever model provider you want to use. We have to pay for Claude used in the demo. No, so as I was emphasizing, you can use any model that you want to use with any harness, right? So it totally depends on you. You can use it with Olama as well. So if you, as we saw here in OpenCloud, it supports Olama, which is totally free. Depends on the compute you have, and there are many people like there are uh, many providers that give you decent level limits on using open source models that they host. So what are the providers that they allow? You can see here that Open Cloud near Olama, right? So Olama is there. Are there any generic harness frameworks that are available, or making custom one is the only option for pen testing agents? So you can use community tools. It is on number 25 on Hack the Box. So that is a specialized one that we built for penetration testing. And as I explained, we have OpenClaw, we have Hermes, and multiple agent frameworks like that. So I will paste these links here. So this is community tools. This is Hermes. This is one is generic. And again, I think many of you must have used OpenClaw. It's also generic. Please share Transilion's GitHub link. Can we build a melting garbage with that? Right. Didn't get your question, Vishal. Is demo over? I missed because of internet connection. No, the agent is going through it. Just opening it up. Okay. Okay. Let me start a fresh session. Okay, I have a fresh URL. So I'm giving it back. And then we will walk through its steps, what it did. And guys, feel free to ask more questions. I'm open to answering more questions. You can unmute yourself and ask questions. Please be more interactive. It's not like a lecture that I'm giving, right? So ask whatever questions you have, whatever use case you're trying to implement, all of that.
Sir, I want to build a harness like Claude Code, but specifically for cybersecurity perspective for pen testing. So I want to design my prompts in that way. So it will just be used for pen testing. So I really wanted to. I just started exploring this thing. What agent loops is like. What's graph engineering, loop engineering, how to integrate MCB tools and everything. But I'm still learning. I need some time, like few months. But what are top few things you will recommend that these things I must have to implement in that harness?
So as all of this stuff that I mentioned, right? The progressive disclosure, the balance of latent space and deterministic space, what tool calls you have defined, all of that you need to take care of. So a good example of it is community tools. You can do that if you want to do it for a particular use case, I suggest. And for a general use case, you can see the Hermes, right? For example, in OpenClaw, if you want to really have the agency, OpenClaw has a notion of heartbeat that the agent wakes up after certain time and checks what's what, right? What's going on. So uh, all of that are I will say tail end problems, but start with the very fundamentals that I will say thin harness, fat skills, good separation of concerns, make sure your tools are right, the balance between the latent space and tennis space is right, right? The self learning part of it, all of that. Did that answer your question, Samir?
Sure.
Cool. What's the limitation of this Claude or any AI to do web pen test? Will it be able to do a critical false, or I need a paid version? So the harness is able to do it. You can we have run it with DeepSeek and Kimi K3, so it has solved even the hack the box fortresses. So it is definitely able to do complicated attacks, right? I can walk you through a couple of them later on after this session. But yeah, it depends on the what are the limitations your model provider is enforcing you on. Apart from Claude or any popular AI tools can do pen testing. Yeah, I think you can use Codex and even Hermes for penetration testing. I've seen people use them. I've seen people manage their context on Obsidian. But yeah, you can definitely do that. If you want to really do that, use some open source provider running on your on premises. And the very first starting step for you shall be Olama, right? Because you can download a smaller model and run it right there on your laptop, and then iterate from there. How to make sure the model agent we are using is not exposing any confidential information, right? So that is an AI security question that I have got. Uh, so that is another 90-minute discussion. But at the very fundamental level, uh, you need to define like the controls that you are setting up in your hooks, in your tool calls, right? So, for example, you not want the web fetch tool to uh, be used, or artifact creation tool to be used when you are querying the database, right? So what you do is that when you create a skill of how to use ClickHouse CLI to access my database, you define what are the tool calls that you can do. You can just run, let's say, Python start, right? So you can just allow that Python scripts to be executed, right? And if you have just one Python script that reads a database and gives you some context, then what your agent is already permitted to do is to execute that Python script that gives you back that context without using web fetch or creating an artifact, or even crazy stuff like deleting your database. Yeah. The integrity has NVB and if set up on Olama and use AI for recon any system requirements. So, see, system requirements entirely depends on the model that you're using. And to be very honest with you, the best of the best results will be used with the best of the best frontier models. So, start with Olama, but like for India AI has this AI coach compute where you can rent compute like library. So India AI coach. So you can uh, uh, check this out. So this is a government of India initiative to provide affordable compute. So you can have collab like notebooks and all here, right? So check this out. Can we build the multi-agent setup for pen testing with surveillance database sources? Yeah, that is the multi-agentic setup. So that is the agent that we have built up exactly for uh, penetration testing. So it is for AI-powered autonomous penetration testing, bug bounty hunting, and security research. That's what it is intended for. When an autonomous agent with CLI permission scans an untrusted code base, how do you enforce the trust boundary so that indirect formalization embedded inside code comment or string can't trick the agent into running unauthorized commands. So yeah, it boils down to running the unauthorized commands, right? So it boils down to what are the access that you are giving uh, to that particular agent. So what you need to do is one of the simplest ways to do it is that the deep research use case that we're taking is that you have an agent that just gathers the context and uh, writes down the structure of what that agent is inside inside a format, and then you have predefined workflows and hooks to it that you have deterministic mechanisms to check if the prompt injection uh, is not there, right? And then once you have all of these things there, then you easily that agent that has more controls of writing the code or executing the code. Can we input skills.md to ChatGPT or Gemini simple AI? What that I'm assuming will that may work or not. So see, when you open this ChatGPT or Gemini in your browser, what happens is they are not just they're agent sitting on top of a frontend, right? So they're not just LLMs working on your skill side. So if you want to have daily control over what you're building and amend it, the best way is to use a programmatic mode. Build it yourself. Even like for simple tasks, you can obviously create a skill.md for deep research. But yeah, for sophisticated use cases like building our own agentic sword, that is not recommended. That's not how it will be done. What do you think about the uses of Claude and AWS Bedrock for autonomous pen testing? Yeah, go ahead. You can try that. As a college student, I want to build a web penetration testing project and create with AI. Can you give me some project ideas about it? Yeah, I have project ideas that you can go and build the out. And as I said, I can explore how we have done that in community tools. I mentioned the link above in this chat, so you can check that out. Cool. So let's see what our agent has done. So it has solved the lab. What it did is that it enumerated the usernames, and then one of them, give it the oracle that for this you have incorrect password, right? And then what it did is that instead of doing 100 cross 100 operations, it did it in 100 plus 100, right? So the agent, instead of brute forcing the attack, it found the oracle and then did that in much less time. So the credentials are AQ/Charlie, and it signed up in uh, this particular lab. So it has solved this, right? So I can go to my account and check. Looks like there's some network issue here, but yeah, this lab has been solved. So yeah, check it out. Try running this Sportsfigure lab yourself. Hey, thanks for the demo. This looks impressive, but since Sportsfigure labs already have hundreds of write-ups available in which model was being trained on, isn't data contamination issue here? However, the agent actually perform on real world engagement or bug bounty stuff where no public declaration exists. Have you guys benchmarked it yet? Yeah. So I will show you the all of stuff that the agent is doing. I can show you the messages in the slides itself. So it has solved the I don't know right link to a black box profile, but I will somehow sometime later share with Mazdad. But it has upskilled itself. So whatever use case you see there, much of them have been written by the agent itself as it has explored. And it has moved its ranking from 800 to 25 and solved the hide the box challenges and purchases itself without us explicitly guiding it, right? So if you see here, it gives us progress update uh, on a daily basis that this is what I saw, that wave encryption I saw, what is remaining, and here is what I'm thinking, all of that, right? So you can try it with some hack the box challenge. I didn't specifically use Fortress because that is also the challenge that we are facing. Is we are now shifting to some open source LLMs for this our open source project because of clause restrictions, or you cannot do cybersecurity operations. So yeah, I don't have Kimi Ketari hosted right next to me, so that's why. And for the lack of time, I chose a simpler lab. But yeah, you can try it out yourself. As I've done, right? Just can clone it and then try running it with your Kimi on an hack the box lab, and then you can always reach out to me. Is pen testing consumes more tokens than development? So it depends, my friend, on what we're developing and what kind of penetration testing that you're doing. This card makes so many noises. So yeah, so that's where the moat lies, right? When we discuss where the moat lies is how do you build an entire vertical specific stuff. The moat is in you build an AI native SAS. So I will publish an article on this thing soon, but learn about this concept of service as software, right? When you are seeing SaaS is dying, SAS is the future in verticals. That you build the softwares that treat the surface first, that they give the customer right in the face of the application the value that I say, hey, am I okay as a CISO? Yes, you are okay. And this is what I'm doing. Right? So SAS is the future. AI native SAS is the future, right? So explore this concept. So thing is, how do you manage that ownership? How do you manage memory over the uh, long context? How you build your multi-agentic system, and how it really acts like a human, right? It does not gives you so much noise, right? Like the how the humans usually communicate. It is able to communicate in that manner. Did I miss any question? No, I don't think so. Any more questions that we have here? Feel free, guys, to unmute. You can always reach out to me later on as well, but feel free to unmute and discuss. We want to apply CVP to do all stuffs and part. Yeah, they have this partnership program, and then also I think we did that, but even in that case, it's a bit sophisticated. It's not that straightforward. You need to mail them, hey, can we use Fable for this and all sorts of that thing. And I think that's how more and more people are moving towards open source AI, because of this stuff that they did, that their own agent, reached their production, and now you cannot use the same agent to figure out what happened, right? So, and then you are running your models on your own time to figure out how it all happened, right? So, that's what the current state of the market is, that you host your own LLM and make it do whatever you want. But yeah, for learning all of this, solving, even the expert level Portugal labs, all of it, I don't think so. You need the CVP. Uh, but yeah, if you are solving a hack the box fortress, yes, you need it. Any doubts, guys? Anything you don't understand? Anything you need clarification on? You can ask questions about the FD stuff as well, because I've been an FD for about 2 years now, working on both the customer and the development side. So you can ask questions there as well, whatever you want to ask. Can you suggest best open source model in Olama for pen test? So that is Kimi K3. These guys use models every day, so they might have used something today. But yeah, as far as the rest of my knowledge, they just Kimi K3. Here is the FD roadmap for cybersecurity. Cool. I don't have a roadmap handy, but sure, I will prepare and share. FD possibility for cybersecurity folks and its pathway. Okay. So yeah, I will walk you through. See, FD is more like, it's more about soft skills than hard skills, right? It is about understanding what the user wants, and then communicating it to the user, right, and setting the intent right, reading in between the lines. All of those sales stuff that we discussed, all that is required in the FD. So the notion came from, what used to happen is with AI development is happening so fast, and Palantir introduced this, is that uh, whenever user wants a new feature, there is a ticket, and then that goes through a cycle, and there is a UX design, and then there's a development cycle, and then there is a testing cycle, and then there's a release cycle, and you release it. And then as a customer, I'm waiting for 3 months to get something that I wanted to use today. And because of that, since development is becoming so fast, the customer is already switched to a new provider to give the same service. They will not wait for you to develop that. So from there, the concept of FD came, right? So on that, I think I have written a post on the same. I will share that post to you guys so that you can understand. Uh, Here, my screen is not visible. I'm sharing my screen.
Your screen is not visible.
Yeah, I'm just sharing my screen. So I did this post some time back. So- Yeah, here. So if you're moving from a developer to FD, this is a checklist that you need to take care in mind, right? So all of this stuff that I was mentioning, reading in between the lines, creating playbooks, etc. Right? So if you are a security engineer and moving to an FD, can check this out. So the average package, I think it is higher than average if you're just a developer, especially in US, but totally depends from company to company. It's reusing method of not really helping or it expires and stuff. Yeah, so it depends what you're doing. Again, so if you're using a Portugal lab, it will not. But if you let's say you're using tracking some hack the box fortress where the user needs to, the agent needs to try out different type paths, and it might go on for hours. You need a paid one or use an open source and self-hosted. There are providers as well as I said that give you decent enough limits. Uh, for example, this one, right, Open Router. So it is a unified interface for LLMs, and they give you some, they host the models for you, so that you not need not to have compute, and they many times they give you offers on the new models that they put. So if you are not, let's say, spamming them or using them for some enterprise purpose or your self-learning purpose, you can use these LLMs. Cool. Any other questions we have? I think Mazad, we are good to wrap up. If you guys have any questions, you can reach out to me. Yeah. We are trying to test various open source pen testing agents, and we are experimenting between using them and cloud hosted LLMs and trying to which would have given good results have good using ability and same thing also as well have been observations of these, especially local hosted LLMs. Yeah, we tried with Kimi and DeepSeek. 6 months back, we ran the benchmark. They were not as good as Opus 4.6 at that point of time, but we are running the benchmark again. So that is in process. I have access to Claude Code, and but it was companies developing purposes out of use for security or something also. Um, Say Claude, if you are really going on for the harder side of the black box, I will say do not use Claude Code because you might end up in a problem. Problem as in it might sometimes work, might sometimes not work. Try to use Open Router or some self-hosted LLM. For learning purposes, you can use.
Uh, I hope I'm audible.
Yes. Yeah.
Are there any more questions or
Yeah, so for false plus positives, as I mentioned, Adil, you have to build the harness the right way, as in the right balance of latent and deterministic space, right? So it really depends on what kind of hallucinations you're getting to give you maybe the specific solution for it. But ensure that there are the 7 evals that I mentioned. All of those evals have been implemented. The right hooks have been implemented, and you have those verifier patterns.
Shashwat, while you are taking questions, I'm just going to share the Discord. Uh,
Sure.
just wanted to check if everyone could see the channel that I hope the Claude for Security channel is visible to you all. If you guys are there in the Discord, just check and let me know because it seems like some people can see it, the others can't. Shashwat, you can take over.
Sorry. Hello. Um, your voice broke off, Mazad, last.
You can continue, Shashwat.
Okay, cool. I think yeah, which is those things.
This in
So yeah, use a pi system based harness plus Kimi K3. That is best for now. No, it's not visible, Mustad. Mustad, it is visible to me. We wish you can please start your internet connection and so on. And others can confirm as well if it is visible to you. Schema K3 need more system requirements. Yeah, it is a pretty big model. Let me show you. Share with you its system card. Yeah, so you can check this. Any other questions we have? I think that we don't have any other questions. Looks like.
Okay, then I guess we wrap this up, right? It has been a big session. What I will do is I will share all the requirements and all the stuff through email, obviously through Discord as well as the WhatsApp. And obviously Shashwat will be accessible. I will be sharing his LinkedIn. Any other thing, Shashwat, you want to share with me, you can share it and we will get it done. That's all, guys. Thank you for coming. We'll hopefully see you in the next session. Thank you.
Thank you so much, guys. Thanks. Bye.